Tristan, you're up.
All right, thank you. Thank you very much. So my name is Tristan. I work in the area of cybernetics. So cybernetics is a branch of science that analyzes and looks at the behaviors of systems in which information feedback mechanisms play a big role. And this is something very important to agriculture, and I think it will transform the way we look at the management of agricultural systems, especially as digital technologies start to find way into agriculture and data becomes available for doing some of these tasks. So let's, for example, consider a crop system where we have a crop, we have pests and diseases, and we have a soil. So these are components that interact with each other, and there are feedback mechanisms in there in which they exchange information. And obviously these components get affected by weather, but fortunately get also affected by management. And this is what, for example, farmers use in order to develop desired behaviors and also make those behaviors robust, especially to the aspects that they have uncertainty about. And how is that done? Well, that's done, again, is through feedback, but now it's an artificial loop, it's a created loop. So we collect data, we put that data through analytics, mathematical models, and we get information, which is data in context in relation to the decision problems that we're trying to do. And again, so here we have a system with natural feedback loops and artificial created feedback loops. And feedback is a great tool. It allows you to do two things, to shape the behaviors of the systems, but also to achieve robustness. However, even though it's a great tool, it can also a tool that is subject to fundamental limitations. And if we don't understand those limitations when we manage these type of systems, this can lead to underwhelming results. So cybernetics brings tools from other areas that are dedicated specifically to the analysis of these systems. So let me give you an example. So this is some of the robot technology that we're trying to commercialize at the university that I've been leading a project for over a few years. So this is a crop management system for protected cropping, whether it's in greenhouses. So this is a full system that can do the management of the crop, can monitor the health, and so the robot uses information from vision sensors. That information not only tell us where the crop is, but also can tell us what the quality is. And so therefore this can be used to monitoring crop growth, but also if we combine this one, for example, with physiological models, with the right data, then we can forecast. And this can introduce new ways of doing some of the business. For example, some of the growers could be trading short-term future contracts, which they're not doing at the moment. The robot can also manage the crop in terms of managing pests and diseases, but also harvesting. And this is fundamental to avoid waste. For example, at the moment, robotic harvesting is the only way that we can go in terms of doing what we call selective harvesting, which means that each piece of fruit is harvested at the optimum time. So this is one example there. So just in the big picture, so I think in the future as data becomes more available and we combine technologies, for the yellow bits, with systems knowledge and together with elements of human factors and biology, I think agricultural cybernetics will play a big role and will transform the way in which we look at management of agricultural systems. Thank you very much indeed.